Welcome to the Clearing Your Tracks section of this course. This is going to be the final section of this course, and within this section we're going to be covering the process of how to clear your tracks on both Windows and Linux. All right, and this is a very important section, and it's coming at the end of this course primarily because this is where it belongs, and I'm going to be explaining a few important things to actually keep in mind as you actually go about clearing your tracks, right? So let's get started with how to clear your tracks on Windows. Now, before we explore a practical demonstration, I need to explain a few things, right? So the exploitation and post-exploitation phases of a penetration test will typically involve actively engaging with target systems and the data that is stored on these systems. Now, this is very important because if we use an example or an analogy, the example I'm going to be using is, let's say you've been contracted to perform a penetration test on a small to medium-sized business or company that has maybe about 20 systems, right? And within the rules of engagement, the client and yourself or your company that you represent agree upon specific guidelines regarding the interaction of the penetration tester, with the client's systems, during and after exploitation. So during the exploitation phase and post-exploitation phase. And what the client will essentially stipulate is that there are certain things that you can and cannot do. And of course, you might have a good idea as to what this is. This is all pertinent to the operation of these target systems and the data that is stored on these target systems. So if you're performing a pen test on 10 or 15 systems, and these are systems that are used by employees, they could be servers that are hosting web applications and business critical applications, then the client will essentially tell you, hey, once you gain access to the target system, I don't want you to manipulate anything. I don't want you to create any user accounts. I don't want you to modify anything pertinent to the operating system. So I don't want you to delete or modify the Windows registry. Essentially, I don't want you to do anything that could jeopardize the integrity of the operating system and consequently lead to that operating system failing, which would consequently lead to data loss. And this also applies to the, to the web applications or applications that are running on that operating system. And so this, the process of clearing your tracks and, the post-exploitation phase of a penetration test really needs to be in alignment with the rules of engagement that you have agreed upon with the client, right? And this is something that you will get an understanding of before you begin the penetration test. So as a result, you may be required to clear or undo any changes you have made to the target systems you have compromised based on the guidelines specified in the rules of engagement. So in certain cases, a client could tell you, okay, once you gain access to a target system, you could create another user account just to showcase what a real attacker would do or an adversary would do. However, when you're done with your penetration test, you need to go back to all of these systems and you need to delete those user accounts. That's just an example. So again, keep the rules of engagement in mind, before you begin the penetration test, and make sure that you refer to them at every step or every phase of the penetration test. So if you've transferred any files to the target systems that you have compromised, keep track of where they have been saved or stored so that you can remove them or delete them when you're done. And as a good practice that I actually recommended during the transferring files section of this course is to store all your scripts, exploits, executables, and binaries in the operating system relevant temp directories. So if you've exploited or gained access to a Windows system and you want to transfer some files onto it, don't just blindly upload or transfer the files to the desktop of a specific user account or to the downloads directory. Store them within the temp directory. There's two reasons why you should be doing this. Firstly, you'll know where everything that you've transferred is saved. So you know that whatever you transferred onto the target systems is stored within the temp directory. So there's a singular centralized location where you're storing everything. Secondly, in the context of defense evasion, this will essentially storing your exploits and scripts within a temp directory is a good practice, primarily because it is not a frequently accessed folder, and users will not really be able to tell whether the system has been compromised because all the files are stored within a directory that they don't really or frequently access. And the same goes for Linux, right? If you're transferring files, scripts, exploits, or binaries, transfer them to the TMP directory, which is the just the temp directory for Linux. So do keep that in mind. And as I said, if you've done this and you follow this good practice, then once you're done with your penetration test, you can easily go back to the temp folder and delete everything from it. And that's it. All the artifacts or all the files that you transferred onto that target system are gone. Now, it is also important to consider the exploitation framework that you are using. An example of this is the Metasploit framework, exploit or post-exploitation framework, whatever you're using MSF for. Now, MSF, or the Metasploit framework, is notorious for generating and storing artifacts on the target system when using exploit or post-exploitation modules. So you might have seen this within this course. When we used a specific exploit module or post-exploitation module, after running it, it may tell you that that module was unable to delete the artifact or the script that it transferred to the target system, and as a result you need to delete it manually, and it provides you with the path to that particular file. So whenever you're running Metasploit framework exploit or post-exploitation modules, pay close attention to the output generated by that module when you run it, as it will tell you whether it's generating any artifacts, and if so, where they can be found if it is unable to delete them. Because some well-developed Metasploit framework exploit and post-exploitation modules are actually very, very useful in that once they have transferred a script or an executable onto the target system for the purpose of gaining access. So for example, if it sends a stage in order for you to obtain a interpreter session, if they're well developed, it may actually go ahead and delete it for you so that you don't have to do it yourself. Now, this is not a rule. This is the exception. So, as I said, the Metasploit framework modules or the Metasploit framework itself is something that you need to take into consideration for your pen tests, and you need to be very good at understanding what these modules are doing in the context of transferring files onto the target systems, and what or whether or not they are interacting with specific Windows or Linux features that you probably or might not have the permission to do. So for example, if a Metasploit framework exploit or post-exploitation module is interacting with the Windows registry, and the client has stipulated within the rules of engagement that you are not allowed to interact with the Windows registry, then do not use that module, because again, you're going to end up making changes to the Windows registry that could be very difficult to delete remotely or through your interpreter session. So keep that in mind. Now, again, coming back to some well-designed MSF modules, some of them will provide you with instructions and resource scripts that provide you with information regarding where the artifacts are stored and how they can be removed. And in the context of resource scripts, some well-developed MSF modules will generate a resource script that you can run on that target system to undo whatever the module did in the first place. So for example, if we're using a post-exploitation persistence module on Windows, and it creates a new service and a new executable, and all of that data is transferred onto the target system, that is quite a messy situation to deal with, and as a result, it generates a resource script that you can run on the target system, and it will delete the payload or the executable that was transferred. It will also delete the service, etc., etc. Now, one additional thing that you'll typically find, especially when it comes down to Windows, is that a typical post-exploitation technique that is pertinent to clearing your tracks is to delete the Windows event log. So this is something that I have covered in the Metasploit framework course, and I did that to showcase how it can be done. However, in the context of a penetration test, this is something that should be avoided completely, because the Windows event log is essentially a database of logs pertinent to the system, the security, authentication attempts, etc. And this information or the data stored within the Windows event log is very, very important to the company, as it gives them an idea as to what has been done on that system, whether the ability to identify successful and unsuccessful authentication attempts, so on and so forth. So again, this is something that will and should be stipulated within the rules of engagement. So you need to agree, you actually need to sit down with the client and agree upon what you can do in terms of clearing your tracks. And on the client's perspective, or from the client's perspective, this is something that they will typically refuse you to do, because that information is very important. And if you're performing a red team operation, or you're trying to emulate a particular adversary, and one of the techniques that these APT teams or adversaries use is to delete or to clear the Windows event log, then the company might agree to that. However, it's something that I would not recommend that you do. All right, primarily because the data stored within the Windows event log is very important, and that event log is rarely cleared, because it sort of gives the company or the person using that system a very good historical overview of everything that has been done on that system, from a security perspective to a system perspective. So what users logged on, what programs were installed, what updates were installed, what commands were executed, was a PowerShell command executed, etc. With that being said, this video has a lab environment attached to it, and it's not really going to be that practical. I'm just going to be showcasing a few examples of of what this would look like, or how to clear your tracks on Windows. And the techniques that I'll be highlighting will essentially abide by what I've stated within the slides. All right, so I'll fire up the lab environment and I'll see you there. All right, so I'm back within the lab environment, and you'll be provided with the target IP address. And of course, in your case, it's going to be different. All you need to do is just copy it. So what we're going to be doing is we're going to be simulating exploitation and post-exploitation, and we'll be keeping in mind, the artifacts that we're generating, and I'll showcase a few examples of how they can be cleared, right? And we're going to be utilizing the Metasploit framework, for exploitation and post-exploitation. So we'll just perform a quick nmap scan on the target system to identify the vulnerable service that is running. So I'll say nmap SV, and the vulnerable service is running on port 80. I'll paste in the target IP, and I'll give this a couple of seconds. All right, so the nmap scan is complete. As you can see, the port 80 is open, and we have Bad Blue version 2.7 running on it. We already know that there is an exploit module for this specific version of Bad Blue. So we'll open up MSF console here, and I'll just search for that particular exploit module. So I'll say search Bad Blue. And the one we want to use is this one right over here. So that has an ID of 1. So I'm going to say use 1. And let's show this particular payload or this particular module's options. So if I say options, you can see that it's utilizing the following payload. So it's using the 32-bit Meterpreter payload, which makes sense because we don't really know what the target operating system architecture is. We then need to set the target IP. So I'll say set rhosts, and I'll paste that in there. And if I show advanced, this will show me advanced options pertinent to this particular exploit module. Now, this is something that's very important because it will essentially, these advanced options give you a better understanding as to what this module does. And in the context of clearing your tracks and, getting rid of artifacts, this is very important. So again, the objective here is to try and identify, whether we can find an option that is pertinent to, whether or not this module generates, specific artifacts and whether it automatically deletes them. So we can also show info to get an idea of what this module does. So you can see that this module exploits a stack buffer overflow and the pass-through functionality in the external DLL file in Bad Blue version 2.72, B, and earlier. All right, so if we type in exploit, this will provide us with access to the target system, as you can see here. All right, so it sends the stage and it gives us a Meterpreter session. So if we say sysinfo, we can see that the target operating system is Windows Server 2016 and the architecture is 64-bit. Okay, so let's migrate to explorer.exe. But before we do that, let's check out our user privileges. So get use ID, we currently have access to the target system as the administrator user. So we'll say pgrep explorer and we'll migrate to that process ID. So 4032. We'll give this a couple of seconds. There we are. If I say sysinfo, this should be a 64-bit Meterpreter session. All right, so let's take a look at the first recommendation that I made within the slides, and that is pertinent to where you transfer or store files on the target system. As I said, it's always recommended to store them within the actual temp directory. So if I say ls, you can see that this is the root of the C drive. The temp directory is typically stored in the root of the C drive on Windows, and you can create it if it doesn't exist. So I can say make directory temp. All right. And if I navigate into the temp directory, this is where you should be storing all your files. And so if if you want to transfer or upload a local enumeration script, this is where you should upload it to. If you're uploading a binary like WinPs or an exploit binary, a privilege escalation exploit, upload them to the temp directory so that you know that everything is in one centralized location. All right. So for example, I can say if I wanted to upload a file, so I can say upload share, user share, Windows binaries, and let's find an example that we can use here. Let's say we wanted to upload netcat.exe. I'll upload it to this directory, and when I'm done with the pen test, I can just navigate to the temp directory and get rid of all the files that I transferred. So remove netcat.exe, and that is done. All right, so that's the first recommendation. The next recommendation ties into the Metasploit framework exploitation and post-exploitation modules, right? So during the Windows persistence section, we utilized a couple of persistence modules that generated a lot of artifacts, right? So an example of this would be, a module that the actual persistence service module that generated a persistent service, right? And I'll just put this in the background and showcase how that would work. So I'll say search and, persistence, and I'll say platform Windows. And this is the module here. Let's see if I can find it. There we are. Persistent service. So I'll say use module 2, right? And this is a post-exploitation module. So I can say show options, and I'll just change the L port to a different one because port 4444 is running. So I can set that to 4433. There we are. And we can then set the session ID. So I'll say set session 1. Now, this module is a good example of when you need to actually, delete or get rid or clear your tracks, because this is a post-exploitation module that will, again, generate an executable, transfer it over to the target system, and then create a service, a persistent service. So if I say show info, you can see that this module will generate and upload an executable to a remote host. Next, it will then make it a persistent service. It'll create a new service which will start the payload whenever the service is running. So again, persistence is something that is very important. However, it leaves a lot of artifacts on the target system. And as part of the rules of engagement, when you're done with the pen test, you need to get rid of all of this. You cannot have this running on the system that you've compromised, because if an attacker, a real attacker, finds this running, then they could potentially exploit it, and then you will be responsible for that company or for your client being exploited. So never leave anything that could be useful for a real attacker or adversary on the target system. So we can run this. I'll just say exploit, and you'll see, because this is a well-developed post-exploitation module, it'll give you some very, very important resources. So you can see that it'll again run the module against the target system. The Meterpreter service executable is written to the following directory. So keep this in mind. Always note this down. In this case, it stored the executable under C users, administrator, app data, local, temp, and this is the name of the executable. So let's actually see whether this is the case. All right, so I'll navigate to the root of the C drive. I'll say cd users, cd administrator, cd app data, cd local, cd temp. And if we list out the files within this directory, you can see that that is actually there. And this tells you where it's written, so you can remove it manually if you want to. However, because this is a well-developed module, it will tell you that it's generated a clean up Meterpreter resource script file. A resource script, as I've already highlighted within the Metasploit framework course, is a script that is used within the Metasploit framework to automate a specific task that you want to perform with MSF console, right? In this case, this resource script, if we can actually copy the path to it here, and that's very important, so also note that down. I'm just going to open up a new tab and I'll cat the content of that resource script. You can see that when we run it on the target system, it will stop that service that was generated, the persistent service. It'll then delete the service. It'll then utilize taskkill.exe to essentially kill that particular process, and it has the relative string or the name of the process or service for that matter. And then it will also delete that particular executable for you that was transferred to the target system. So this is extremely useful because you don't need to do it manually if a resource script is generated for you. So the next question is, how do I use this particular resource script? Well, firstly, you need to use it, or you need to run it on the target system. So this is the actual persistent service meterpreter session. So I'll just exit from it, right? And you can see we still have session 1 running. So I'll say sessions 1. And in order to run a resource script, you simply say resource. Let me type that in correctly. So resource, if I can actually type it correctly, and then you specify the path to the resource script. So I'll hit enter, and you will see that this will clear up everything for you. So firstly, it'll tell you that it'll actually stop the service. It'll then delete the service. It'll then kill that particular process or service. And in this case, it tells us that the process has been terminated, and this one as well has been terminated. And then the file, the executable that was transferred, that was stored under the administrator user directory under app data local temp, has been deleted. So we can actually confirm this and see whether this is the case. So I've navigated to that particular directory, and you can see that that file has been deleted. So that's fantastic. All the artifacts that were generated and the services that were created have all been deleted. And this is something that is very, very, very important, especially during a real penetration test. So again, this was one example of how to closely identify the actual output or artifacts that are generated by a Metasploit framework module, whether it be an exploitation module or post-exploitation module. And in the event that it provides you with a resource script, that's how to use it, a cleanup resource script, how to use it. And, in this case, we've been able to confirm that we've essentially undone what we did. And in this case, we got rid of the persistent service. All right. Now, the final recommendation that I made within the slides was of course pertinent to clearing the Windows event logs. Now, Meterpreter has an inbuilt command that will clear the entire Windows event log on the target. It's called clear EV. As I said, this is something that I recommend you stay away from until you know what you're doing, because if I hit enter, this is going to clear the entire Windows event log on the target system. So let me just show you this. This is, for the sake of demonstration. I'll hit enter. And you can see it's going to wipe 165 records from the application logs, from the 764 records from the system logs, and 2,558 records from the security logs. Now, this is something that is really not useful for the client because, again, as I said, unless you're performing adversary emulation, which is part of red teaming, then if you're performing a standard pen test, then you don't need to do this. You can simply highlight that an attacker within your pen test report, you can highlight that an attacker could potentially do this. And that's something that the client needs to be aware of. So yeah, that's really all that I wanted to cover. As I said, most of this section or this phase of post-exploitation will tie into your understanding of what you're able to do, and that of course needs to be in accordance with the rules of engagement. And furthermore, keep track and keep a note of where you're transferring files to. Understand that the Metasploit framework modules also generate files and artifacts, and they need to be deleted once you're done. Do keep a note of what modules you're using, and of course be very cognizant of the fact that you can potentially damage a system by interacting with specific, in the case of Windows, specific Windows features like the registry, etc., etc. And of course, never be in a position where you need to, you run an exploit that could potentially cause the system to, to shut down, or to cause the kernel to go into a kernel panic, and primarily because that could lead to data loss. So that is going to conclude the practical demonstration side of this video. All right, now that we've explored the process of clearing your tracks on a Windows system, we can now move on to how to clear your tracks on a Linux system. So I'll be seeing you in the next video.